Good day, this is the Professopher, CBMG PhD, and today's Monday, January 9th, 2023. It is 5:03 and 24 seconds, a.m. Eastern Standard Time, and today's research, Embryogenesis. So let's hop to it here. As telling left from right, cilia and cellular force sensors during embryogenesis, date January 5th, 2023. Source: Massachusetts General Hospital. A new study now reveals that cilia and the organizer function as sensors for mechanical force exerted by flow to shape the left-right body plan of the developing embryo. The left-right asymmetry is known to be established during early embryogenesis by a small cluster of cells termed the left-right organizer. Within the organizer, motile cilia, hair-like structures on the cell surfaces meet rapidly to create a leftward directional flow of extracellular fluid, which is a first outward sign of a left-right difference. And this early flow has been shown to be critical to the distinction of right from left. However, how this flow is sensed and translated into left-right asymmetry has been unknown. A new study led by researchers now reveal that cilia and the organizer function as the creators of the flow. They also act as sensors for the biomechanical forces exerted by the flow to shape the left-right body plan of the developing embryo. Nearly 25 years of work by numerous groups have shown that cilia and flow in the organizer are absolutely essential for establishing body left-right asymmetry, but researchers haven't had the right tools or techniques to definitively study how this all works. And to overcome this challenge, the researchers utilized zebrafish as a model for left-right development and employed a novel optical toolkit consisting of custom-built microscopy and machine learning analysis. And their approach was unique as they developed and deployed optical tweezers, a biophysical tool that uses light to hold and move microscopic objects similar to a tractor beam that enable precise delivery of mechanical force onto cilia in an intact living animal for the first time. Utilizing these tools, the researchers discovered that cilia are cell surface mechanosensors that are important for left-right asymmetry of the developing body and organs such as the heart. And by using optical tweezers to apply mechanical force onto cilia in the left-right organizer of zebrafish, they showed that a subset of organizer cilia sense and translate flow forces into calcium signals that control left-right development in zebrafish. The defects at left-right asymmetry are associated with numerous human disorders, including heterotexas syndrome, primary ciliary dyskinesia, and congenital heart disease. The knowledge gleaned from this study not only advances our understanding of the fundamental cellular processes that govern the development of the human body, they may also open new avenues for the development of novel diagnostics of these disorders. Additionally, this scientific work may pave the way for targeted therapies on cilia signaling and mechanosensing to improve outcomes. The researchers continue to investigate the molecular mechanisms that govern cilia force sensing. They also continue to develop new strategies to visualize and manipulate cilia signaling with a long-term goal of developing novel tools for the treatment of cilia-associated disorders. And this is the Professor, Professor of Microbiology, Bioinformatics, and Pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.